Hi students, in this video we are going to learn about equation of plane passing through coplanar lines. Otherwise, we can say that there will be two lines and we will find out the condition for those two lines to fall on the same plane. After finding the condition for two lines on the same plane, we will find out the equation of the plane that contains those two lines as well. So first we will consider two lines. Whenever we talk about lines, we need dr, that is direction ratio, and the point through which the line passes. Hence we are considering a line L1 whose direction ratios are a1, b1, c1, and the line passes through the point x1, y1, z1. Here two lines are there, hence we must consider another line as well. Here we will consider another line L2 whose direction ratio is a2, b2, c2, and it passes through x2, y2, z2. There are two conditions. When two lines are given means two conditions are there. One is when these two lines are parallel to each other. When these two lines are parallel, definitely it must be coplanar only. And then where those two lines are non-parallel. So we will consider this case 1 L1 and L2, that is line 1 and line 2 are parallel. In this case definitely L1 and L2 are coplanar. When L1 is parallel to L2 means, as per the free vector concept, we can move this one line towards another line, and even we can place one line on the another line. Hence definitely it must fall on the they must fall on the same plane. So when line 1 and line 2 are parallel means definitely those two lines must be coplanar line only. Then now we move on to next concept, that is line 1 and line 2 are non-parallel lines. When those two lines are non-parallel lines, then what are the conditions those two lines must satisfy to be coplanar lines? We will see one by one. Now we are considering a plane whose Cartesian equation is ax plus by plus cz is equal to d. Now what we do is we are just considering a plane. Assume that any one of those lines fall on this plane. Let us assume that L1 falls on this plane. Then the coordinates of the line 1 must satisfy the plane equation. Let the line L1 passes through the plane, then we know that L1 passes through x1, y1, z1. Hence this coordinates, x coordinate, y coordinate, z coordinate must satisfy this plane equation. So in place of x we are substituting x1, in place of y we are substituting y1, in place of z we are substituting z1 equal to d. We know that a, b, c are direction ratios, they are constant values. So x1, y1, z1 is also coordinates, that means they are also numerical value. Hence constant into constant provides constant. This is also constant. When we add all these constants together, we are getting the value of d, which is in constant, that can be substituted in this equation d. I hope you understand this problem. So what we do is we are just in place of d we are substituting ax1 plus by1 plus cz1, and then we are transferring them to the opposite side, and when we simplify it we are getting this equation. We already saw this equation as equation of a plane which passes through one point, that is if the point through which the plane passes means the equation of the plane can be written in this form, that is a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Suppose that the line 1 and line 2 are coplanar. Now we assume that line 2 also lies on the same plane. That means the coordinates of the line must satisfy the plane equation which contains the first line. That is, this equation must satisfy the coordinates of L2, that is line 2. We know that line 2 passes through x2, y2, z2. Hence In this equation, in place of x, y and z, we can substitute x2, y2, z2. Now this is the equation of the plane which contains both line 1 and line 2. I hope you understand up to this. Now we will consider the normal to the plane. Normal to the plane means normal is a straight line which is perpendicular to the given plane. When these two lines fall on the same plane, definitely the normal to the plane must be perpendicular to L1 and L2. When two lines are perpendicular to each other means their sum of the product of the drs, corresponding drs value is equal to 0. That we already learned. So normal value, we know that dr of the normal is given by the general equation of the plane, that is coefficient of x, coefficient of y, coefficient of z gives the dr of the normal of the plane. So and this one line 1 and line 2 have drs as a1 a2 sorry a1 b1 c1, dr of l2 is a2 b2 c2. Hence plane is perpendicular, normal is perpendicular to plane means definitely that normal must be perpendicular to line 1 and line 2. Hence this equation a into a1 plus b into b1 plus c into c1 equal to 0, a into a2 plus b into b2 plus c into c2 equal to 0. Now we have these three equations. We have unknown values a, b, c because we do not know the value dr of the plane a, b, c because the plane equation is in the general form ax plus by plus cz is equal to d. So using the cross multiplication method, we are eliminating this ABC from 3, 4, C. We get this condition, that is x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2. They are in indeterminate. If this determinant value is equal to 0 means, then we can say that those two lines are coplanar lines, which is the required condition for the lines to be coplanar. Hence when two lines are given means we need to calculate the dr of the first line and then dr of the second line and the point through which the first line passes and the point through which the second line passes. Using them we need to find out this determinant value. If the determinant value is equal to 0 means we can say that those two lines are coplanar lines. If they are coplanar line means then we need to find out the plane which contains those two lines, which is given by eliminating ABC from 2, 4 and 5. 2, 4 and 5 we get this expression x minus x1 determinant of x minus x1, y minus y1, z minus z1, a1 b1 c1, a2 b2 c2, which is equal to 0. This is the equation of the required plane which contains these two lines. I hope you understand this. I repeat it once again. If you want to find out whether two lines are coplanar or not, we need to find out the corresponding drs and the point through which it passes through, and then we need to find out the determinant value. If this determinant value equal to 0, those two given lines are coplanar. And in case if we want to find out the plane which contains these two lines means we need to use this determinant form, the x minus x1, y minus y1, z minus z1, a1 b1 c1, a2 b2 c2, and determinant value is equal to 0. I hope you understand this concept. Based on this concept we will solve some problems. Thank you students. Thanks for your cooperation.